Alright, in this video we're going to be talking about how to find the curve of best curve of best fit for an exponential function. So we're going to start with how do we do this in the calculator. So all the steps are going to be on these notes, but I'm going to, in my calculator, first clear it out. Second plus 712, so I can restart it, and that way you can follow along with me. I'll also do this. Okay, and then we are going to go into Stat, go into Edit, which is it's already on, and then we're going to put our numbers in L1 and L2. Make this a little bit bigger. Alright, so in L1, -2, -1, 0, 1, 2. And then in the other side, in my online calculator, I can do alpha y equals, but if you're doing it on the handheld, you may have to just type in 1 divided by 4, and it may not give you the fraction part, but that's okay. Half, and then 1, 2, 4. And because we're dealing with exponential functions, so remember that previously we have dealt with lines of best fit, linear regression, quadratic curve of best fit, quadratic regression. So now we're going to go into exponential regression. So in step 2, we're going to go back to Stat, scroll over to Calculate, and then we're going to go all the way down until you see exponential or EXP regression. So that's the one we're going to use. Excuse me. And then, just like before, make sure your, X's are in L1, Y's are in L2. And then if we need to use this for data purposes, you would store this in the regression equation. So I'm going to go ahead and do that. Alpha trace. Store it in one of the equations and hit enter 3 times. And then it will give us our equation that looks like the format. Remember, we talked about that format before, y equals a times b to the x. So when we write our curve of best fit, that would be y equals, my board is being weird, 1 times 2 to the x, or you can just write y equals 2 to the x. Then we want to predict the y value for some different x values. So because I stored this, if I go into y equals, my equation is there, so I can go into the table and look for these values. When x is 3, y is 8. When x is 4, y is 16. And then if I go up, when y is at -4, it's at 0.0625, or 1/16. And at, oops, I put that in the wrong spot. When x is at -3, it's 0.125, or 1/8. And that is how we find the curve of best fit for an exponential function, how you can use the calculator to find other values. Remember that you can use the table, you can go to the graph, and type in, go to second trace, look for different values when x is different values. So if I put in when x is 3, it'll tell me what that is. If I do it again, when x is -3, again, it'll tell me what that is. So you can use that. Or you could go to the main screen, set one of the numbers to be x. So let's say I put 3 store x, and then I grab my equation from alpha trace. Then it's going to put x into my equation and solve that for me. So you have different ways to do that. Then in Desmos, just like with line and curve, with linear regression and quadratic regression, it's easier in Desmos, same thing here. So in Desmos, if I hit the table, and then put in a table, put in my x and y values, -2, -1. Remember that if you start to make a pattern, it'll recognize the pattern, you can hit enter. And then I can type in 1/4. You can also put in 0.25, it doesn't matter. 1/2, 1, 2, and 4. And then I'm going to hit the plus so that I can see my points. I'm going to get rid of this for just a second. Alright, so we can see the points in here. And then in another line, I'm going to type in, kind of similar to our quadratic regression, our linear regression, we're going to use y1. Our tilde, this squiggly line. We want it in the format a times b to the x. So we want a times b raised to the x1. Oops, except that's not what I typed. There we go. Come back. There we go. And then it will give you the line, the curve of best fit. It'll tell you what your A and B values are. And just like with your linear regression and quadratic regression, if you type in your actual equation, y equals 2 raised to the x power, it should overlap. Oh, except I put 2 equals. And it would overlap the given one. And that's how you know you did that right. So we're going to go back and forth between the calculator and Desmos just so you see both. But first we're going to talk about this. So you need to be able to distinguish the 3 types of functions we've talked about this year. Linear functions, quadratic functions, and exponential functions. More so in this unit, quadratic versus exponential, but also there might be some linear stuff in there too. So looking at the graphs, you should recognize that these 3 graphs are different. So I'm going to make this bigger just so we have all 3. Linear, of course, is a line. It keeps going on forever and ever. Quadratic, we talked about, is a U shape. That's the parabola. In one direction, it's going to keep going up or down. And it goes up or down together. But then it comes back to the same point. And then the exponential we've been talking about. And that starts at 1, keeps going to the other side, and it exponentially gets bigger over time. The equations for those 3, we know lines are y equals mx plus b. We talked about that since the beginning of the year. Quadratics we're still diving into, but that's our y equals ax squared plus bx plus c. We've seen a lot of that in factoring and our polynomial stuff. And then our exponentials, y equals a times b raised to the x power. And then your regression equations are also given there as well. Keep that in mind. So we're going to do these 3 just to kind of look at, okay, I'm given a bunch of ordered pairs. I have to figure out what's what and kind of go from there. So in the directions it says, graph each set of ordered pairs, determine whether the ordered pairs represent a linear function, a quadratic function, or an exponential function. And then if the function is quadratic or exponential, find the equation of the curve of best fit. So we don't want to find the line of best fit because we did that already. We want to focus on the curve of best fit for the 2 things we don't know. There was a typo in number 1, so I'm just going to fix that really fast. This should have been 1, 1, not that. So I'm going to go ahead and graph all of the points first. And as I start to graph, you should be able to see what type of function it looks like. So we have -2, -7, 0, -3, 1, 1, 3, 3, 5, 7. In number 2, we have -3, 2, -2, -1, -1, -2, 0, -1, 1, 2. And then in number 3, we have -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. So, remember that your line of best fit or your curve of best fit may not go through all of your points. It's just the line or curve that best fits the data. So I can see that this is going to be some sort of linear function. It may not touch every point. This makes a U shape. So that's going to be a quadratic. And then this makes that curve shape. And that's going to be your exponential function. So then to find the curve of best fit, we're not going to do that for the first one, but we will do that for the last two. So we'll do the quadratic in the calculator just as a refresher, and then the exponential in Desmos. Okay, so in the calculator for the second one, I'm going to go into Stat, go into Edit, and I need the points -3, -2, -1, 0, and 1. And then in this, I'm just going to clear this out. And then I need the points 2, -1, -2, -1, 2. And then I'm going to go into Stat again, scroll over to Calc, number 5, quadratic regression. And I just need the equation, so I'm not going to store it this time. And I'm given the format, so this is going to be y equals 1, or you can leave it off, x squared plus 2x minus 1. And if I were to graph that over top of the points, it should match up. So just so you kind of see, I didn't store it though. We'll do that for the next one. For your lines, you see that they're kind of increasing. Your x values are increasing and your y values are increasing or decreasing, but in the same amount. Your quadratics, your x values keep increasing by 1 or 2 or whatever, but the y values tend to come back to the same point. We start at 2, we go down to -1, we go down to -2, but then we come back up to -1, we come back up to 2. And then our exponential and then in Desmos, since I already had an exponential up here, I'm just going to use the same one. Oh, this happens to be the exact same one. Okay, so because the points are already in there and they're the same, I know that this is going to be the equation y equals 2x. And we see that the points overlap. So then, now that we know the difference and what the graphs look like, how the points are going to look, the biggest thing here is once you find your points and you figure out what type of function it is, that you use the correct type of regression. You don't want to use a quadratic regression for an exponential and vice versa. Now we're going to get into some of our problems. So in the last video, we talked a lot about quadratic regression problems and other examples. So this time we're going to focus on the exponential. And I'm just going to tell you what those are, or what these are anyway. So we're going to start at 11. So the table shows the number of book club members for 4 consecutive years. Determine which model best represents the data. So as I'm looking at this data, I see the x's keep going up by 1. But in the y's, I see these multiplied by 2, and then it keeps multiplying by 2. When you see something like that, that should tell you it's exponential. You're multiplying by some whole number or some fraction each time. So I'm pretty sure this is going to be exponential, but I tried to make that a star, but my board didn't like that. There we go. So I'm going to use the calculator for this one and then desmos for the last one. So I'm going to go into stat, go into edit, clear out my lists, and then go ahead and put in my values, 0, 1, 2, 3, 4, and 5, 10, 20, 40, 80. And then I'm going to go into stat, go over to calculate, and then down to 0, because I think it's exponential. And then because I'm going to be using the data to answer other questions, I'm going to store this, alpha trace, and I see that this equation would be y equals 5 times 2 to the x. Or you could put it as the dot. I am going to go into StatPlot for 1 second. I don't think that was it. It was stat diagnostics. Okay. And I'm going to go and I'm going to turn that on. And you'll see why here in just a second. I'm going to turn the StatPlot off. So when I have my stat diagnostics on, I can look at the correlation coefficient. Remember that's determines how well this line best fits this data. And it can go from -1 to 1 depending on the correlation, if it's strong, weak, positive, negative. But because this correlation coefficient, the R-squared value, is 1, I can say that this best fits this data. There's nothing else that would fit this. I could try the quadratic just to see. But if I look at the R-squared data, it is close to 0.99, but it's not 1. So we want it as accurate as possible, and the 1 gives us that. So it will be exponential. Trying to write, and the board doesn't want me to. Okay. Okay, then it's asking how many members would there be in 8 years. So I'm just going to go into the table and look when x is 8. And say that there would be 1,280 members in 8 years, because it would keep doubling. And you can see that in the table that it keeps doubling. Okay. In 13, another problem, we're going to do this one in desmos. The value of a car depreciates over time. So just in case you're wondering what that means, it starts having some value. Let's say your parents or you bought a car for, let's say this price, $18,500. In 5 years, 10 years, 15 years, however many years, even in 1 year, that price that you bought it at will not be, the car will not have the same value. It will go down in value, decrease in value. Continuing on, the table shows the value of a car over a period of time. So I'm going to put in these values. Notice that in real life problems you can't have negative numbers because that wouldn't make sense. And then the initial value was 18,500. Then we have 15,910, and then we have 13,682.6, and then we have 11,767.04, and then 10,119.65. So as I'm looking at this, I see that this function is going down over time, which, again, that tracks, that makes sense because the value is going down over time. And I see that this curve is exponential. So the curve of best fit for that one, using my equation, would be 18,500, y equals 18,500 times 0.86 raised to the x power. And in Desmos, if I needed to find how much the car worth after 7 years, well, my x value is years. So if I were to type in x equals 7 and find where those two lines cross, it would be worth about $6,436 and let's say 67 cents. So it would drop down a lot the more time that has passed. Now that we've gone through some examples, let me show you this really fast. I'm just going to type in my quadratic regression just to show you that this wouldn't work the best. So y1 tilde ax1 squared plus bx1 plus c. So if we, okay. So what happens is the points fall on the quadratic, so we actually end up getting the same correlation coefficient of 1, the r squared equals 1. But because the exponential comes back up, car values don't usually come back up unless they're ancient or historic. So the quadratic regression value wouldn't make sense to use that. Okay. Now that you've seen this, come see me with any questions you have. You have this time to practice.